continue straight from last video where we look at the spacing. We calculate the spacing of the reinforcement. Let's say you don't have these tables with you. Okay, you can develop these tables. You can just pause this video and you can develop in the Microsoft Word and you can keep these tables with you. But let's say you don't have these tables. Now if you don't have these tables, how are you going to work it out manually, any spacings? Okay, let's say, okay, you have let's say do one case, let's say spacing at midspan, and you want to find out the spacing. Let's say you know the area, which is 393 millimeters square per meters. So what happens here, let me draw this 1 meter wide strip, and there is n12 bars and 393 millimeters square bar, and depth of the slab is 150 millimeters. So first we find the area of the n12 bar, which is the 12 millimeter diameter, is equal to area of 1 bar is pi by 4 times diameter square. Give me 130 millimeters square. That is the area of 1 bar, cross section area of 1 bar. Now if I want to calculate the spacing, what is the spacing? Let's say this spacing, which I am going to write it down. Let's say this is the spacing S. Let's say I want to know what is the spacing here I should provide. So I know the area of the one rio, which is 113 millimeters square, divided by the total area that is required in 1 meters, that is 393 millimeters square. That we found it. That has two check pass, minimum area requirement and the shrinkage, crack control of temperature and shrinkage effect. So that has correct reinforcement area. So that is 393 millimeters square per meter times by this 1000 millimeter width. So that is 1000 meter or 1 meter or 1000 millimeters. Just we are working in millimeters, so I put in millimeters. So if you just simplify that, you will get 287 millimeter as a spacing. Now please note, we are not going to specify 287 in the structural drawing. The builder will not going to go and measure 287 millimeter distance. Generally, we rounding off to the 10 millimeters. So every 10 millimeter increment that we round off, and please round off less than 287. Do not round up the more than 287. So do not round at 290. Okay, that will be sometimes over designing. We need to make sure we have smaller specified. That will have a conservative solution. So we always, if you get, let's say 292, you rounding off 290. Let's say you got 265, rounding off to 260. Here we get 287, so rounding off 280 millimeters. So if you go back in our calculations, again we have 280 millimeter that we found, which is close enough. So if you don't have the tables, as I mentioned again, if you don't have these tables, don't worry, you can do this manual calculation. Still it is correct, but just making sure that you just convert this one into 10 minus 10 rounding off. So whatever you get, you just minus that number here. If you have 7 here, minus 7. If you have 5 here, minus 5, and so on. So that is 280. Now one more final check that Australian standard wants you to do, that is called minimum spacing requirement in clause 9.5.1b. Okay, so if you go back here in the clause 9.5, that is called crack control of the slab. So the standard wants to control the crack, and general requirement for North Force concrete cap. I encourage you to read this one. Minimum area requirement, clause 9.1.1, we already done that. In the B, if you come back here, they say that center to center spacing of the bar in each direction shall not exceed the lesser of this one. So we can say that for crack control of the same, minimum spacing would be minimum of 2 ds or 300 millimeters. So ds is the depth of the slab, that's we saw in the previous video, 150 millimeters. So I substitute 150, 300. So that is saying that 300 millimeters. It says in any directions. It's independent of your where the slab is located. So for example, if I just show you, okay, if you have anywhere, if you're designing any slab, it's depend on your depth of the slabs. Okay, so here, anywhere you designing it, you must satisfy this 300 millimeters requirement. So someone said design this one, you must satisfy. This is independent of where your slab located. Okay, so for any locations you must satisfy this requirement. Let's check it out. Okay, we have some calculation done. So the first one we done 280 millimeters center distance. Alright, let's check it out. If 280 millimeter is less than 300 millimeters, that is okay. That is perfect. There's no problem. Okay, we can adopt this 20. And before I forget, why this minimum spacing requirement is specified in the standard? It is just for controlling the crack. So if you have these two reinforcement far, if you are sitting too far, then your crack will travel through this reinforcement. It's like a soldier in your army. You don't want to put on the border, let's say this is line of control, you don't want to put your soldiers very apart, so your enemy will start, let's say crack is our enemy, this enemy will going to get in, so you want to stop this enemy, the crack. So if you want to stop your enemy coming from into the concrete, you would have these soldiers that you want to put too close to each other, and the standards say that you can put the soldiers mean the reinforcement. The standards say that you put your soldiers close to each other, which is minimum 300 millimeter. In case if you calculated is greater than, let's say you calculated 350 millimeters, okay, in that case if it is not satisfy the requirement, then you convert your 300 millimeter into 350 millimeter into 300 millimeter, but here we satisfy, so we need to take it to 180 millimeters. Second, you have 280 millimeter at discontinuous edge, again it specify that is okay. For continuous edge 250 millimeters, we calculate 250 millimeter, that is okay. So all these three spacing requirement is satisfy the minimum spacing requirement that is given in the clause 9.5.1.b, and this is the final check for the reinforcement. For reinforcement, I just summarize what we done. I think we assume the depth of the slab. Let me write it down the steps so it can helpful. So we assume the trial depth, and then we done the deem to conform check, and then we calculate the mx positive and mx negative values for continuous and discontinuous, and then we calculate the as at different locations, and then we done the two checks here. One is for creep and shrinkage, shrinkage and temperature control effect, and we also satisfy the minimum AST requirement, and we need to pass that both check. Once you pass that one, you calculate the spacing of the reinforcement as, and once you calculate the spacing of the as, you making sure that as is less than your as minimum value. So that's the final calculations that we done. So we then follow that step. So that is the x direction primary reinforcements, and now in the following videos we will continue solving, like let's say we will do the deflection serviceability check, deflection calculation, so how much beam will deflect, that we're going to do the calculation in next video. So continue watching this series of videos. The next one is coming up to do the calculation of this deflection of the slab. Thank you.